So for this experiment, you're being introduced to a couple of new concepts. And in particular, there's one type of calculation that you're going to have to do for this that it might seem a little bit daunting. Chances are that you're just about to start discussing it in your Chem 1341 class. And if you haven't, you will be in the very short future. Now, what this calculation is converting from a mass of a substance to the number of moles of a substance. Now, we've set up the lab manual so that it's a little bit intuitive for how to do that and making it as kind of direct and simple as possible. As an example, this is page number 21 in your lab manual, part 3, the data set that you're going to collect for this. You're going to have a mass of a substance, and right below that is your molar mass of the substance, and right below that is the number of moles of the substance. So what you're going to do is something that looks a little bit like this. So let's say, hypothetically, that we're talking about working with the calculations for NaCl, sodium chloride. And let's say that as your IA directs you, you get a certain mass. And let's say that you're supposed to get 3 grams, but you instead get 2.85 grams. So you get 2.85 grams of that sodium chloride. Below that in your data sheet, you'll see the molar mass for NaCl is 58.44, that's a 4.44 grams per mole. So what that tells you is that the mass of 1 mole of sodium chloride is 58.44 grams. So another way to look at that is if you had 58.44 grams of sodium chloride, that would mean you have 1 mole of sodium chloride. Now in this case, we have 2.85 grams of sodium chloride. 2.85 is considerably less than 58.44. So we know that we have less than 1 mole, but how much less? Now, to answer that question, what we're going to do is we're just going to take 2.85 and divide it by 58.44. I'll use my calculator to do that, and I will learn that 2.85 divided by 58.44 is equal to 0.04. I'm going to call it 0.0488 moles of NaCl. Now, if you were to write this using scientific notation, it would be written in the following way. You'd find the first non-zero digit, which is 4, and put a decimal right next to that, 4.88 times 10. Now the tricky part is, what is that times 10 to the 5th, negative 5th? What is it? Well, in this case, what we're going to do is we're going to move our decimal place 1, 2 positions. So I'm going to write this as 4.88 times 10 to the negative 2nd moles of NaCl. So 4.88 times 10 to the negative 2nd moles of NaCl, or 0.0488 moles of NaCl. So this is the number of moles of NaCl that we have. All that we did was we took the mass that we used and divided by the molar mass. Okay, so that's the first part of our calculations. The next part of our calculation asks us for the molarity. Now, molarity is something that in the event that, or it's something that you're going to be getting into in a couple of weeks whenever you're talking about solutions. For the purposes of this class, or for the purposes of this calculation, all that you need to know is it is number of moles of a substance divided by number of liters. So if you have, in our case, what we have is we have 100 milliliters of solution, or 0.1 liters, because 1,000 milliliters is equal to 1 liter. Therefore, 100 milliliters, which 100 is 1/10 of 1,000, 100 milliliters is equal to 0.1 liters. So what we're going to do is we're going to take our, and I just like to write it kind of longhand like this, and I will write out 0.0488 divided by 0.1. So I'll take that 0.0488 divided by 0.1, and I will get 0.488 molar, so big M. So we have a solution. We're working with a solution that is 0.488 molar NaCl. Okay, so that tells us the approximate amount or number of moles of NaCl that are present in 1 liter of our solution. We're only working with 100 milliliters of our solution, which is why we have divided by 0.1 liter. Okay, now the last calculations that we're going to work with. So the last calculation we're going to work with, I'm going to segment this off, is a dilution calculation. So this calculation is sometimes referred to as C1V1 equals C2V2. You might sometimes see it as M1V1 equals M2V2, but for our purposes, I'm going to go with C1V1 equals C2V2. So what this C stands for is concentration. So V1 is the volume. C2 is also concentration, and V2 is also volume. So effectively, this is a calculation that's very useful for what we're doing when we go from our initial solution to our first dilution, and then from our first dilution to our second dilution. So I'm going to go up to this 0.488 molar. That is the solution that we prepared. We prepared 100 milliliters of that. Now we prepared 100 milliliters of that solution, and what did we do? We ultimately discarded 50 milliliters. So, or sorry, we ultimately preserved and used 50 milliliters of it. So what I'm going to do is I'm going to say my initial concentration, or my C1, is 0.488. Okay, now my V1 is the volume of that initial solution that I used. That is going to be, I'm going to write it as 50. And I'm going to keep it as 50 milliliters, not converting it into liters or anything like that, because of the fact that my final volume is going to be in milliliters as well. So I'm going to say that's 50. Now, that is going to be equal to C2. That's the concentration of my dilution. I don't know what that concentration is, but that's what I'm looking for. So I'm going to label this as C2. Now, V2 is the final volume of my new solution. The final volume is 100 milliliters. And we know that because what we did was we prepared our solution. We prepared 100 milliliters of our solution, transferred, or after we did our experimental trial, we transferred 50 milliliters to our grad cylinder, then discarded the rest. That 50 mils of our grad cylinder went back into our volumetric flask. When it went back into our volumetric flask, was there NaCl in there? There absolutely was. So we added deionized water to bring our total volume up to 100 milliliters, which is where this comes from right here. So in order to figure out what C2 is, I'm going to say 0.488. I'm going to plug in 0.488 times 50 equals C2 times 100. But then what I'm going to do is I'm going to say, so 0.488 times 50 is 24.4. That is equal to C2 times 100. I'm going to divide each side by 100. And from this, what I'm going to learn is that C2 is equal to 0.244. So that's the new concentration of my first dilution, or that's the concentration, I'm sorry, of NaCl in my new solution. So that's 0.244 molar. Which if you think about, you had a stock solution, you took half of it and got rid of it and added an equal volume of that half to make a new solution. All right, well, these calculations are something that you're definitely going to encounter in your 1341 class in the coming weeks. I hope that this was helpful. You can definitely refer back to this. This is going to be useful for when you're doing the experiment this upcoming week or this week in lab, and I hope this was helpful. All right, well, have a good one.